Hello, my name is Clint Hayes. I teach at Eaton School in Eatonia. I teach a variety of classes, including middle years and high school phys ed, PAA, math, and science. I'm doing this video because I'm part-time Pebble mentor in our school, and this will serve as our year-end summary. I'm going to talk primarily about my use of computational thinking and coding in the classroom, and hopefully it will provide some ideas or resources for anyone wanting to bring coding into their classroom, but isn't really sure where to begin. So I'll start with a big disclaimer. I am not an expert in coding by any means, so if I can do this, pretty much anyone can. When starting or when introducing coding, I always start by taking a class or so to explain what computational thinking is. Computational thinking is more or less thinking in a way so that a computer can understand. As humans, we have the ability to think logically and to deduce things. Computers can't do this, and they need a set of very detailed instructions or code to accomplish tasks. For example, if you were trying to explain to a computer how to get a robot from point A to point B, you would have to break it down into each individual movement or action, such as turn 30 degrees to the right and then move 3 spaces forward. So one small group activity I do when teaching this is asking for a volunteer. The volunteer gets blindfolded and an object is placed somewhere in the room. The other members of the group have to take turns verbally guiding that person to find the object and pick it up. Each turn must only cover a single command, such as turn from 12 o'clock to 3 o'clock. The next person might say, take 3 steps forward, and so on and so forth. I will sometimes time the groups as an indicator of the efficiency of their instructions or their code, and it becomes a competition. So from here, I usually transition to block coding using the computer program Scratch. Block coding is using pre-made blocks that represent small sections of code. Students put these blocks of code together in a sequence that would make sense to a computer. I've discovered a couple of good digital resources for block coding that include modules and activities for students to work through. They do require you to register and obtain a password, but they are free. And I will just share my screen and see if we can get to those now. Okay, so the first one here is scratch.ie. So the pros of this one is that it includes student modules and teacher guides. There is a very good introduction to Scratch. The cons are that some of the modules get a little bit lengthy and some students will lose interest. So what I discovered with this one is that these first 2 modules were free and you didn't have to register. And then the remaining ones, they're still free, but you did have to register in order to get access to those ones here. But nonetheless, that's a pretty good resource that I discovered. A recent one that I discovered just this past year was codingville.ca. I had to register for a teacher's account with this one. It was free, however. But once set up, I was able to set up a classroom, and it includes these different journeys or modules, if you will, that you can assign. And if we went into one of these, we can run through it a little bit. This is a very simple introduction to it. Again, you're using blocks to communicate with the computer to tell a character what to do. So again, this one is very simple. Those are the two blocks that you would use to accomplish this task. And it just goes through it as a game almost. So the pros to this website is that it has neatly animated and engaging, and it's engaging for students. It feels like they are playing a computer game. They are organized as challenges, and students have to guide the character to accomplish certain tasks via code. It transitions students from block coding to using coding languages to junior app development. And the teacher dashboard tracks student progress in real time. So once you're logged in as a teacher, you can actually see which of your students are working and on task and which ones aren't accomplishing a whole lot. It also keeps a record of their achievement, and it can tell you how many times it took them to get, how many trials it took them to get a correct response. So this is a feature that I've used the odd time in an assessment. The cons to this website are, we discovered the odd glitch that popped up every now and then. Certain modules, if a student got it wrong the first time, they essentially had to log back out and log back in, and in order to get the correct code, even though they had it put in there correctly. But they were just minor things that may have been fixed by now, I'm not sure. So after block coding, I started introducing coding languages to the students. Coding languages are very much like languages that we would use. They use different formats to communicate with computers. The one we use the most in our classroom is Python. We do several different coding projects using a Raspberry Pi computer and other components. One project the students really like is the Pixel Pet project, where we use a Sense hat and an add-on board for the Raspberry Pi to control a series of LED lights that create a digital pet. And I have a little example of that project in this video right here. All right, so when it comes to the Raspberry Pi projects that I do, Google is my friend, and that's really where I look to get all of the information I have ever gotten. There's lots of online tutorials that do a really good job of explaining how to build the various different projects. All right, well, that's getting close to wrapping things up. I think if you can bear with me for a second, I might transition here and just move the camera over to, are we still there? Looks like we're still there. To show one of the Raspberry Pi stations that I have set up in my classroom. There, I'll do my best to show you what I have here. So essentially it's a little computer, complete with a keyboard and a mouse. The Raspberry Pi itself is this little guy. You can get it in view right there. That's the little tiny computer that includes all the different components. We have a breadboard beside it. That's what this thing is here. This particular student had it wired with an LED in a circuit that includes a switch. So the LED could be turned on and off with the switch. You can also hook this up to the Raspberry Pi and control the LEDs with the Raspberry Pi. One Christmas, a couple of years ago, I had a student that really took to this, and I had her wire in a series of LED lights, and she was able to use the Raspberry Pi to write a program to make the lights blink in time to different Christmas carols. So she did one for Christmas Tree and various other, I think Frosty the Snowman was another one she coded, and that was kind of a fun little activity that she did. The noise you're hearing in the background is my classroom pet. I'll just show you a little introduction to those guys. These guys are axolotls. I've had them since the fall. They're managing COVID quite nicely. They're pretty easy to take care of. They get fed a few times a week from my worm farm that I have on the go here. In these containers, I have a bunch of worms that they eat. These guys are native to Mexico. They're extremely endangered in the wild. They only live in a single lake just outside of Mexico City, but they do really, really well in captivity, and they're a fairly common pet. So kind of a neat addition to my classroom. Kids have really enjoyed these. They've enjoyed learning about them. Completely nothing to do with coding, but I thought I'd just explain what that noise was. And another interesting thing, I guess, is our 3D printer. I've got one in my classroom. This was just a cheap one I bought that I had to assemble, and that was a pain. One of the brackets had broke. If I can zoom in properly and get that green bracket there on the screen. So the original bracket broke, but I was able to download a program to print another one off with another 3D printer we have in our school. And I was just kind of in the process of getting it reassembled when closures hit. So it's kind of sat here not being used ever since. I think I'll maybe wrap it up here. I'm sure there is a ton more things I could have covered, but I tried to keep it fairly quick and fairly simple. So that's kind of how I introduce coding into my classroom and have utilized it. Again, I think it's a very important skill for students to have nowadays. And it really, if students have a working knowledge of coding, it could really open up a lot of job opportunities for them in the future. All right, thank you.